All right. Oh, it's so hot in here. Okay, so question 34 of the W3 Resource. And I solved the question. Now, I looked up um, how to compute the area of a hexagon, even though the challenge or the question number 34 gives you here a procedure. Okay. But I thought the area of the hexagon was something a little simpler, so I looked up online, and there is a simpler way to do it. It's just like this. Okay. For that is for a regular hexagon. Okay. But I just went ahead and coded two answers to the question. One with the simpler operations that Google and YouTube teaches you, which is the apothand divided by 2 um, times perimeter times 6. Okay, it's equal to the area of a hexagon, regular hexagon, both sides the same. All right, and then I also coded the answer that the system, what that is, the challenge requires. So what I did to answer with the formula of the W3 Resource is I replace the symbols sides right here, exponent 2 right here. Okay, tangent right here, pi right here. So I replace the symbols using the math class within Java, which makes it all easier, right? Instead of doing manual calculations and putting manual numbers. Okay, this is still core Java. So the tangent, the value of the tangent will be pi divided by the perimeter, the number of sides, okay, which is 6. And then, so the result of this is the value of the tangent. So we feed for the tangent to be processed and calculated. Then that's times timed by 4. And so this code right here, that's what that does. First, we have the inner parentheses, which calculates what is pi, Math.PI divided by 6. Okay, that is passed as an argument for the Math.tangent function, which is then multiplied by 4. Now, all of that is divided then by 6 times sides, or the length of the side, raised to the power of 2. Okay, raised to the power of 2, which you can see side raised to the power of 2. This is how you do it using the Math.power function. The Math.power function takes 2 arguments, and that is the first one, argument that will be raised to the power of the second argument. Okay, and so if we run this code using the first Google procedure, okay, and the formula, we'll see what results we get. Okay, and you will notice that there is an object variable here. Explain what that is. First, let's use this. Apothand. This is what you're going to find in Google or YouTube if you look it up. Simple procedure. First see it on the top. Okay. Perimeter times the side, the number of sides in a hexagon, which is 6. Okay, so coming back over here, you notice that I have an object variable that is type of the class, the name of the class. That's because I made these methods that I coded instance method because I did not make them static, which is this. And if you don't have a static method or variables, then you cannot use it within a static context, which is what the main method of the Java classes are. These are static contexts. So you have to use an instance of the class, whether that's class 34 or class 33, whatever class that is. In this case, I did it within the same class, outside of the main method as an instant variable. Instant means that each class, okay, each instance of a class can use a copy of this, and the values are going to change depending on what you input into it. If this is static, what that means is that this method and the value that you put into it is the only one that exists. So if you use that method on a different class with the same static variables, the values that you use in this class are going to carry over. And so you're going to constantly be overriding the very same method, very same variables, the very same object. So with an instance method, an instance variable, what the system does is every class that you instantiate, so if this was a question 33, that will be an association of the class 33. Each instantiation of each class will have its own copy of the method. That's what an instance method means, an instance variable. Okay. So in order to use an instance method and instance variables, you need to use an instance of a class, and then use the instance of that class to call its own copy of the method. And that's what that is. So now that we saw that, let's do the second method, instance method, which is the one that uses a formula that the challenge question 34 gives us. So this is the formula, and this is the result. Now we're going to give it as an argument for the side 6, the number 6, because it's the same one that the example gives in the website. And so we will get the same result if I did it right. And of course I did it right. I love coding. Okay. So question 34 successfully answered. All right. Successfully answered. And again, all I had to do, let's close this one for the sake of eliminating distractions. All I had to do was replace the system, the symbols in these operations here, in this formula, with the symbols or the methods or functions that the math class within Java gives me to perform the operations that these symbols will give us. Okay, that's all I had to do. Pretty simple.